Hello everyone, and welcome to the Mat 211 review of matrices. My name is Julia, and I work for the tutoring centers at ASU. So today, let's suppose that A is this matrix here, 3, 1, negative 1, 7, 5, 5, and 0. B is this matrix here, 0, 1, 1, 1, 0, negative 1. And C is this matrix here, 1, 2, 6, 6, 1, and 3. We want to compute 2 times A minus B plus the transpose of C. So usually when we have, a matrix equation like this with several moving parts, it's often easiest to start by multiplying, our matrices that have scalar multipliers and taking our transpose, just so that it's a little easier to write. So let's start with our 2 times A here. With scalar multiplication, so 2A equals 2 times our matrix, which is 3, 5, negative 1, 5, 7, and 0. So this is just a regular number. We're not multiplying it by a matrix. It's just a regular single real valued number. And we call that a scalar value. So with scalar valued multiplication, what we're going to do is we're going to simply multiply this 2, or multiply every entry in this matrix by this 2. So we're going to do what's called multiplying component-wise. So what this means is that we're going to have 3 times 2, 5 times 2, negative 1 times 2, 5 times 2, so for that guy there, 7 times 2, and 0 times 2. So this gives us 6, 10, negative 2, 10 again, 14, and 0. So we have our 2A. So we don't need to compute that. We can just substitute that right into our equation here. Now we also need to know, so we have minus B. If minus B was maybe like minus 3B, then I would say let's go ahead and multiply that scalar in first. But since it's just minus B, we can just use regular subtraction. And that's pretty easy to do, and I'll show you how to do that in a minute. But the last thing I want to look at is this C transpose. So note that if we had said instead of 2A minus B plus C transpose, we had just instead wanted to calculate 2A minus B plus C, we wouldn't be able to do it because C has different dimensions than A and B. C is a 3 rows by 2 column matrix, whereas A is a 2 row by 3 column matrix, and B is also a 2 row by 3 column matrix. So this would have been undefined. But we do have this transpose instead. And what that transpose means is that any column of C is going to become a row of C transpose. So we can just write this here. This would be negative 1, 6, and 1. So we just flip it up to so it's the first column, and now it's going to be the first row. Similarly, we're going to have 2, 6, and 3. And then let's write this 2A up in here too, just so we can erase our screen a little bit. So 6, 10, negative 2, 10, and 14, and 0 there. And we can erase, make ourselves some space, because we have everything we need to get started with our full statement here. So we have 2A minus B plus C transpose. And that's going to be, well, we already have 2A here, so we can just write in the whole thing. 6, 10, negative 2, 10, 14, and 0. We have minus b, which we're just going to write straight from here. So that gives us 0, 1, and 1, 1, 0, and negative 1. And we're going to add in C transpose, which we already figured out over here, which is 1, 2, 6, 6, 1, and 3. And since we took the transpose, we flipped this. Note that this transpose here is a 2 by 3 matrix now. So you just flip the numbers whenever you take the transpose as well, which should make sense because you switch the rows and columns. So now that we have this written out, we just need to add and subtract these matrices. So let's do them, just take care of this subtraction first, rather than trying to do it all at once. That'd be fine too, but it might be easier to do it this way, just to make it clear. So we have, remember, we're going to do this component wise. We have 6 minus 0. So that's going to be 6 for our first entry, first row, first column. We have negative 2 minus 1. So we're going to get a negative 3 here. We have 14 minus 1. So that's going to be 13. We have 10 minus 1. That'll be a 9. We have a 10 minus 0. That'll still be 10. And we have a 0 minus negative 1, which is 0 plus 1. So we have a 1 here. And now we still want to make sure that we add this guy, our C transpose. So that's 1, 2, 6, 6, 1, and 3. So again, we're going to do the same thing. We're going to add component-wise. We got 6 plus 1. So that will be 7. We have negative 3 plus 6. So negative 3 plus 6 is going to be 3. We have 13 plus 1. That's 14. Getting ahead of myself here. We have 9 plus 2. That's going to be 11. 10 plus 6. That's 16. And 1 plus 3. That's going to be 4. So this whole thing here, whoops, equals this matrix here. And that is our final solution. Yay! All right. So that's it for today. Clear that. Go to our next screen. Before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu. And on this website, you can find our tutor search tool. And our tutor search tool can be found either at the main link or by going straight to it via this full link here. And with that tutor search tool, you can find specific tutoring services for your course, for whatever course you're looking for help in. So thanks so much and have a great rest of your day.